Welcome to this tutorial on Retrofit, a powerful type-safe REST API client for Android. Retrofit is developed by Square and is one of the most popular libraries for making network requests in Android applications. Throughout this tutorial, we'll explore how Retrofit simplifies the process of connecting your app to web services and retrieving data from the internet. By the end, you'll understand how to implement network calls efficiently using Retrofit with Kotlin. Retrofit is an HTTP client library specifically designed for Android and Java applications. It's developed and maintained by Square, the same company behind other popular Android libraries. Retrofit allows you to define your API endpoints using a declarative approach through annotations and interfaces. This means you don't have to write complex networking code manually. One of its best features is automatic serialization, which converts JSON responses from the server directly into Kotlin data classes. This type-safe approach reduces errors and makes your code cleaner and easier to maintain. To get started with Retrofit, you need to add two main dependencies to your project. Open your module-level build.gradle.kts file. First, add the Retrofit core library with version 2.9.0. Second, add the JSON converter library, also version 2.9.0. The JSON converter is responsible for converting JSON data from the API into Kotlin objects automatically. After adding these dependencies, sync your project with Gradle files to download and integrate the libraries into your application. Before making any network calls, you must declare the internet permission in your Android manifest file. This permission is required for all applications that need to access the internet. Open your Android manifest.xml file and add the uses permission tag with the name attribute set to android.permission.internet. Without this permission, your app will not be able to make any network requests, and your API calls will fail. This is a mandatory step for any Android app that communicates with remote servers. Now let's define an API interface that describes the endpoints we want to access. In Retrofit, you create a Kotlin interface to represent your API. Each function in this interface corresponds to a specific API endpoint. Using annotations, you specify the HTTP method and the endpoint path. For example, the @GET annotation with the parameter users defines a GET request to the user's endpoint. Notice we're using suspend functions here, which means these functions can be called from Kotlin coroutines for asynchronous execution. The @path annotation allows you to insert dynamic values into the URL, such as a user ID. Retrofit supports all standard HTTP methods through annotations. The @GET annotation is used to retrieve data from the server without modifying anything. The @post annotation sends data to the server to create a new resource. The @PUT annotation is used to update an existing resource with new data. Finally, the @delete annotation removes a resource from the server. Each of these annotations corresponds to a different type of operation you can perform on your API. Understanding when to use each method is fundamental to working with REST-TFL APIs. Retrofit provides powerful ways to add dynamic values to your API requests. Path parameters are used when you need to include a value directly in the URL path. For example, to get a specific user, you use the @path annotation with a placeholder in curly braces in the endpoint string. This replaces the placeholder with the actual value when making the request. Query parameters, on the other hand, are appended to the URL after a question mark. The @query annotation adds these parameters to filter or modify the response. For instance, you can filter users by role by adding role equals admin as a query parameter. To use your API interface, you need to create a Retrofit instance. You do this using the Retrofit Builder class. First, call the base URL method and provide the root URL of your API. Make sure to include the trailing slash at the end. Next, add a converter factory. In this case, we're using JSON converter factory to automatically parse JSON responses into Kotlin objects. Finally, call the build method to create the Retrofit instance. Once you have the Retrofit instance, use the create method and pass your API service interface class to generate an implementation. This generated implementation handles all the networking code for you automatically. Now that everything is set up, let's make an actual network request. Since we defined our API functions as suspend functions, we need to call them from a coroutine scope. In an Android activity or fragment, you can use lifecycle scope.launch to create a coroutine. Inside the coroutine, wrap your API call in a try-catch block to handle potential errors. Call your API service method, and Retrofit will execute the network request asynchronously. If successful, you'll receive the data which you can use to update your user interface. If an exception occurs, such as a network failure or timeout, the catch block will handle it, allowing you to display an appropriate error message to the user. Let's wrap up with some important best practices when using Retrofit. First, always use the singleton pattern for your Retrofit instance. Creating multiple instances wastes memory and resources, so create one instance and reuse it throughout your app's lifecycle. Second, leverage Kotlin coroutines by using suspend functions in your API interface. This makes your code cleaner and easier to read compared to callbacks. Third, always handle errors gracefully. Network requests can fail for many reasons, such as no internet connection, server errors, or timeouts. Implement proper try-catch blocks and provide meaningful error messages to your users. Following these practices will help you build robust and efficient Android applications.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.